we will be talking about the multicast. And in fact, I was talking to some of the college grads where we were talking on some EVPN stuff. And there one of the guy asked me why in the first place we need layer 2. If you guys are familiar with layer 3, layer 2 OSI model, every network engineer should be familiar with this. This guy asked me why we need layer 2 when we have layer 3, which is much more scalable, which is much more predictable. Why in the first place we need communication at layer 2, which primarily EVPN facilitate. But this is not a class on EVPN. Why I'm talking on EVPN? Because there was a similar question that was asked when we have unicast, when we have multicast, or when we'll have broadcast. Why we need these three categories? And the reason for multicast, it's not that your application demands. Because when I answered this student why we need layer 2 for EVPN, because your application needs it. But why you need multicast? Because you need it. Multicast can give you that required efficiency into the network if you run this. And we will talk about those things in this session. Why multicast? A similar set of students were arguing with me when I was first talking about multicast is unicast and broadcast are the subset of multicast. In unicast, you just deliver one copy. In broadcast, you deliver the copy to all the people. And in multicast, basically, you deliver it to selected people. So this too can be a subset of this. While at a conceptual level, this may be true, but we are all network engineers here on the call. For us, this is definitely not true. I will tell you about my first encounter about multicast, but you might have heard this a lot, not only in the networking context, but in the arenas. If you go back to the radio, like we still have radios, by the way, and we still have TVs where this broadcast is what comes. But technically, that is not broadcast. That is something which is multicast. Why multicast? Because you need to tune into a certain frequency to understand or to join that. It is as good as if, I know I don't need to give this basic example, but at one point of time for one project, I was there in Stockholm, Sweden, and we were talking to the customer, and suddenly customer started talking in Swedish. And that's where I was not able to understand anything, but each one who was their native speaker of Swedish was able to understand. That was basically multicast. And that's what I said. This is what you guys are doing is a multicast. And I'm not subscribed to this. So can we switch back to English, please? So that is your multicast from definition perspective. But I given this example of this TV broadcast or radio broadcast. And here one more thing is there, which I normally talk about. You first thing is that you need to tune into that frequency. Whatever that frequency is, you need to listen or you need to tune to listen to that. But the second thing is you need to be in the proper range as well. If you are not into the range, you will not be able to hear this. What does that mean? Do we have any range if we talk about the multicast in the networks? The answer to that is also yes. There are scope that we define on multicast. It can be based on TTL, or it can be based on application level as well, where you restrict your multicast boundary. You define that boundary. And I'm not sure whether you guys have tried it or not. If not, do try it, maybe in an environment where you are more comfortable with. This address 224.0.0.1. This is something which is your all host address. It's a reserved address which is for all the host on your network. Dot 2 is all the routers. And here is what I hear from many customers, that they are not familiar with multicast. Even some of the solutions, if we talk about some leading overlay solutions, for example, I touched on EVPN. They also support ingress replication. Why they support ingress replication? So that you don't need multicast. Just to get rid of multicast, there is this method which is called as ingress replication. It's supported in EVPN. Don't worry if you are not aware of what EVPN is. This is not related at all to this EVPN. What I'm trying to say here is, when it comes to deployment, you definitely have unicast in your network. You definitely have broadcast in your network. You cannot get rid of it if you are using Ethernet. These two things will be there, but you may or may not have multicast. While having it have the benefits, but there is a lack of understanding, which basically people restrict themselves from multicast, or especially on the enterprise side. Let's just get away with multicast. Let's not enable PIM. Let's just have our unicast stuff working. And to support this, I hear one more argument. In fact, this was one very big enterprise customer that I was talking, and we were saying, because you have so and so applications, and the application owners are telling us that they need multicast, so we need to enable it in the fabric. And that's where this customer told me that, Sunil, sometime back you only said that a fabric has infinite bandwidth. That's a statement from a vendor, but more or less it is true also. Then in the fabric, basically you have bandwidth. So even if we send multiple copies of the unicast packet, we will not run out of bandwidth. So why take the pain of multicast? And if you, some of you who are very beginner, I know, if you are not understanding this, stay for another 5 minutes. What I'm talking, you will get that. But the point, whole and soul, that I'm trying to make here, that multicast is something that you may or may not see in the network. But I'm taking my words back here. You will definitely see multicast in the network. Why? How? Because each network run routing protocols. And if they are running routing protocols, OSPF, EIGRP, old friend RIP, they all uses multicast. So multicast is there, whether we know it or not, whether we need to deal with it or not, it is there. It's just that whatever is in your control, sometimes we try to avoid it. For example, routing, if you are using OSPF, there is no way that you can get rid of this address. But there is this application data, that is something you can avoid by using some replication strategies, which I will show you. and get rid of multicast. But that also come with lot of inefficiencies. And those inefficiencies, if you argue with me that it is only that this will consume more bandwidth, not fully true. We will talk about that as well. So there are a couple of points that I have left open. We will be connecting each and every dot. And this session I have scheduled for 1 hour, but I may not be talking for the entire hour. So we will have time for questions. So I used one term called ingress replication. Very simple words. In simply, if I want to describe this, if I want to send the data to these three nodes, this guy need to make 3 copies of it. And this hurt more when I need to send the same data to these 3 devices. That means the source need to make 3 copies of the same packet and send that to all 3 nodes. Bandwidth, even if I discard, as I was saying, even there is a load on this source also, where this has to create today 3 copy. Tomorrow you have 10 resources, 10 hosts which are receiving this. You need to make 10 copy, and day after it can be 100 or even 1000 also. Definitely not a good idea. And with respect to this bandwidth also, I want to take my words back here as well, where I said infinite bandwidth. But if you guys have noticed this entertainment industry, multimedia, we will talk about one case study at some point in these sessions where the content is from HD to Ultra HD, and I don't know what they call it, to this 8K. So this is like your 1080, this is your 4K, and this is your 8K. Think about the bandwidth that this stream take. If you are not using multicast, if this is the case, what will happen to the network when you are working with a customer who have this requirement? This was my second argument to them, because they were from the entertainment industry. Just because of the fear of multicast, let's not burden the network. So with respect to multicast, you basically send a single copy. Your source is happy that it just needs to send a single copy. Each of the node, basically based on this tree formation, generate the copy and deliver it. How basically this happens? There is a lot under the hood, but if I ask you guys a fundamental questions, let's say that from the bandwidth perspective, from the source efficiency perspective, and today the time is for distributed applications who uses this multicast under the hood. So if that is something that convinces you that, okay, we need multicast, what are the fundamental requirement for a multicast? And when I was looking at it, when I was preparing for this session, I drilled down to 3 points. While this may be a basic for some of you, but it is always good to start with the fundamentals. And I remember during our school assemblies, there were these multiple classes, and we used to form group based on certain criteria. And sometimes there is a call out that class 9 student, please come out and go in some direction, let's say. That class 9 student is basically referring to a group of students. Each one of them has their own name, but because call was for class 9, all those 24 students, including me, moved forward and took our position, whatever was asked to us. So, two addresses. One was which just belonged to me, Sunil, and other identity, which is class 9, which was a group identity. In multicast also you need a set of addresses by which a multicast group is identified. And feel free to take a snapshot of these three requirements once I complete it, because this is fundamental. And then if I go back to the previous slide, if we talk about multicast, in this network, there are these set of routers, let's say, that we have. And then other thing that we have is these groups, sorry, these hosts. These are the hosts which want to join multicast. There is something that run here in this part of the network between your host and the router. You basically need to tell to the router that, okay, I need this multicast. And this is a rule in life also. In most cases, if you don't ask it, you don't get it. Some of the folks I see are there from India. There is this Tata Sky ad which used to come earlier, that there is no harm in asking. पूछने में क्या जाता है, right? And if you get, it's a bonus. Same way, this host, if it doesn't ask, it will definitely not get that. But if it asks, it will get it. And again, I'm not talking about broadcast here. So the second thing is, there should be a mechanism via which host can ask for particular group. This is the second requirement. And the third requirement, I need to know where exactly the multicast traffic is coming from, or where exactly it need to go. For example, in your unicast also, if I want to send the traffic from A to B, I need to know where B is. And who is helping me to find where B is? It's the routing protocol. It is the job of the routing protocol to tell me where B is. Same way, in multicast also, there is a routing protocol that allow routers to efficiently deliver the multicast traffic. So first thing, address. Second thing, a language between the host and the routers. And the third thing, the routers should have certain mechanism to deliver the multicast. Router should know where the source is, where the destinations is, or where the receivers are. These are the three requirements. And let's just take one more basic route regarding the addresses. And I am the one who definitely forgot this. So when I was preparing this slide deck and was doing some more search on multicast addresses, what I will be going to show you is something that I was completely forgotten. Maybe you guys may have remembered this, but in case of addressing, if you recall, there were these four, or technically there are five classes in IPv4: class A, class B, class C, and class D. Now that we are running out of IPv4, but this is there since very long time. So class A, the rule says that the first bit is always 0. If we decode a class A address in binary, you will see that the first bit is always 0. That means your class A addresses are 1 to 126, because 127 is reserved. So anything that lies between 1 to 126 because this first bit is 0. This is the restriction. This is your class A. Class B is the digits should be 1, 0 as you see here. So it starts from 128, goes till 191. Class C should be 110. That means it goes from 192 till 223. That's your class C address. And finally come class D, which is 1110. So this starts from 2 to 4, goes till 239. Your multicast address has to be in this range. Start from 2 to 4, goes till 239. And do you guys know when was the first RFC for multicast was written? It was in 1986. Some of us might have not even born by then, but that much old is multicast in networking. It's just that there were issues related to understanding. There were debates that, okay, we don't need multicast. The deployment was not at that scale, but slowly it is picking up. We will talk about certain case studies as well, where multicast has made so many things easier. And even troubleshooting perspective of it is also easy. I will show that glimpse today itself, how basically the troubleshooting should be done if you guys are staying till the end of this session. But there is an approach for that also. And if you follow that approach, which I do, troubleshooting multicast will be easy. So this is something that is from the addressing perspective. But by now you might have guessed that this is the IP address. The address means this is layer 3. What about layer 2? These days, even 90 to 100% of the deployments that we see uses Ethernet. And Ethernet, you assume Ethernet something like a bus. If you want to get into this, if you want to get into that bus, Ethernet does not understand any of these things. It has to be MAC address. If you are getting on that bus, it has to be an Ethernet frame. It has to be a source MAC and a destination MAC. Now, if I want to deliver a multicast on a LAN interface where there are so many Ethernet connections, does that mean that I need a layer 2 multicast address? The answer to that is yes. And we will talk about this. I will show you this. I have talked about OSPF. OSPF uses multicast. Let's say 224.0.0.5 is the address, well-known reserved OSPF address, which OSPF uses. But R1 to R2, you have a neighborship on an Ethernet link. So when you send that OSPF hello, when you send that OSPF packet at layer 3, I agree with you guys, this is the destination. But what will be the destination at layer 2? Has to be a MAC address. Without MAC, Ethernet will not allow you to take that packet, period. So the point that I'm trying to say here is that there is a layer 2 multicast addresses also exist. This is 5, by the way. Sorry for the handwriting. How does this get drive? What basically this address, the corresponding layer 2 address, we will talk about that. But all in all, the point is you have multicast addresses at layer 3. You have multicast addresses at layer 2. And for layer 2, there is basically a mathematical calculation We will talk about that as well to drive this MAC address. These bits are fixed. The rest of the bits that you drive, there is a mathematical calculation that exists. But what is the benefit of that? Math, if any of you have interest in maths, math is very predictable. You either hit the answer right or you hit the answer wrong. There is no intermediate way like any other subjects. So when I say that you use a mathematical calculation to predict the MAC address, what does that mean? That means that my MAC address is also predictable. Predictable means I can predict that MAC address. The advantage for that is that, okay, I need to take only one frame, have wrapped in that Ethernet MAC address, the destination MAC address, which starts with 0.00.00.5e, then blah, blah, blah. It will get delivered to multiple nodes. If it is OSPF, multiple host, if we are delivering multicast on a, listen to me carefully here. But because this is predictable, I don't need a ARP mechanism like the way we do in unicast. If I don't know the MAC address in unicast, what we do, we shout, we do broadcast, who is Sunil? But something like that does not exist for multicast MAC addresses. And we will talk about more on this as well. And multicast routing and the protocol between your host to router. Remember, I showed you 3 points. If we go back here, one is the address that we have briefly discussed. Mechanism by which host and router talk, this is IGMP. And in fact, here also there was one debate that we were doing why we need IGMP in the first place. When somebody want to send a multicast traffic, let's say there is a source which sends the traffic. There are receivers which receives the traffic. This protocol, this side only. Source doesn't need any protocol as such. Source will directly start sending the traffic. It is the receiver which need to ask for that traffic, and that's why they need this IGMP. Why? That is something which cannot be discussed in such a small session. We need a dedicated session for that, so we will talk about that. And then the routing protocol. This also we will discuss later. So in this session, we have only discussed about point number 1 at a high level. With that, multicast advantages. So that is something I have told you guys, but let's just summarize. One, efficiency from bandwidth perspective. And the argument that we normally get from customers that I do have enough bandwidth, so let me just go with replication rather than multicast, does not hold true for all deployments. If you need efficiency, if there are applications which need multicast, go with multicast. Optimized performance. Now your source does not need to create multiple copies of the same packet. It just create one copy, send it. Distributed applications. So these days there are many applications, by the way, which are distributed in nature. Multicast is something which is a heart of the network now, not only in the enterprises, even in the data center also. And that's why multicast is even enhanced. And for some of the advanced users on the call, tenant routed multicast. This is a concept where you take your multicast on an overlay fabric. So these days, If you are working on enterprise, you are working on data center, this is something that is very hard to avoid. And this all started from ACI, then it came to BGP EVPN, then it came to SDXs. So history of overlay in networking is there for quite some time. It's a very rich history. And even there also, we are carrying multicast with some of the solutions like TRM, tenant routed multicast. Multicast, whenever you talk about this, you always see that there is this tree that we talk, your multicast tree, your source tree. So here, the tree that we are talking, even though I have shown you a tilted tree, and tree normally grow from the roots, but multicast distribution tree happens from the opposite side. This is a special tree, this is a fancy tree, a modern tree, whatever you call it, start building up from this side. And once this tree is formed, the traffic that comes, and if this green arrow is good, your life being a network engineer is also good. But if this green arrow have some patches, some problems, then your troubleshooting also start from this side in this direction. Whether my IGMP is there properly or not, the last hop router understood that IGMP request. If it understood, then does it has any pin join which is sent? Is it a source based tree or is it a shared tree? There is a lot that goes under the hood into this. But if you understand the fundamentals, systematic approach to troubleshoot, multicast is not that difficult at all.